Hi, so today we're going to talk about how do we add halogens to organic compounds. So we really only talked about one possible way to do that in the past, and that's if we start with an alkene, we can add HCl. It goes through the carbocation, we get the Markovnikov product, all that other good stuff. But today we're going to talk about what are some other ways that we can do that, and we're going to get into a little bit of radical reactions. So this will be our first kind of official exposure to radical reactions. All right, so if we want to add halogens, making compounds with halogens. Okay, so what we've talked about so far is if we start with an alkene and we treat this with something like HCl, we get the Markovnikov product where the chlorine ends up on the secondary carbon, right? So this is review. You guys have already seen this before. Seen this before. What I want to talk about today is what are some other ways we can do this? And so the first one that we're going to talk about is radical bromination. Now, I know that many of you have already done this in lab, right? And so we'll be able to, hopefully this will be something that makes a lot of sense to you. Radical bromination, so I'm just going to take a structure that looks like this. Radical bromination is when we treat something with Br2 and light. And note that we have no alkenes in here, right? We really only have sp3 carbons, etc. And what we get is we get the bromine attached to the most substituted position where that bromine replaces a hydrogen. So this is a substitution reaction where the bromine replaces a hydrogen. So the hydrogen is here, right? And notice obviously the hydrogen in the starting material, that is replaced by a bromine in the product, right? So that's one option. We can also do a reaction of an alkene. So this is another one. This is radical addition of Hbr. And so in this one, we're going to use obviously HBr, and then we're going to use a radical initiator, which is going to be a peroxide. So I'm just going to use hydrogen peroxide, and then we're going to have, we're going to heat this up. And what you'll get is instead of getting the Markovnikov product where the halogen is added to the secondary position, we're going to get the anti-Markovnikov product where the bromine ends up attached at the primary position. So this is an addition reaction. And it is anti-Markovnikov. Okay. So two radical reactions, both of which add a halogen, in this case bromine, right? One of them we are doing a substitution where we replace the CH bond with a CBr bond. And in the other one, we're doing an addition of HBr. So much like the addition of HCl up here, we're getting rid of the pi bond, we're replacing it with two sigma bonds, only we're switching kind of where these things add. So if we added HBr without peroxides to this compound, we would get bromine on the secondary position. But when we add HBr with peroxide, hydrogen peroxide here, and heat it up, we get the bromine on the less substituted position. We're going to go through the whole mechanism for both of these here in just a minute. The last one we're going to talk about is allylic bromination. I guess technically halogenation, but whatever. So allylic bromination is if we take, let's go back to, we'll do a slightly different compound here. And we're going to use a very specific reagent, NBS. And again, we're going to have to get into the structure of NBS and all this other stuff. But what we're going to do is we're going to add a bromine, and it's going to be in a position that is neighboring that pi bond. And so we'll get something like this, right? So this is not not an addition reaction because the pi bond is still there. So this is another substitution, but it only ever happens at position neighboring a pi bond. Now, hopefully you're thinking, well, positions neighboring pi bonds, we've talked about those before. That sounds like resonance. And of course, resonance is going to play a big role in those. All right, so I've listed the three reactions, the three radical reactions that we're going to talk about: radical bromination, radical addition of HBr, and allylic bromination. These are going to be the three radical reactions that we're going to cover, and they're all going to introduce, well, bromine in this case, but halogens in general. Okay? I'm going to stop this video here, I guess. I'm going to stop this video here, and we'll talk about other ways of introducing halogens in other video lectures for this week. So in the next couple lectures, we're going to go through each of these mechanisms. We're going to do radical bromination, allylic bromination, and radical addition of HBr. So those will be the next three videos. So watch for those.